Hello guys, welcome to my YouTube channel Inside Mathematics, and I'm happy to see you here once again. And in this video we are going to discuss about the exponent concept and the subject of formula or transposition of formula. So in the exponent we have laws of exponent, and the laws of exponent began like this, start like this. For example, if the bases are the same, okay, when we are multiplying and the bases are the same, the law of exponent emphasizes that we add the exponent. Okay? For example, here we are saying 3 power 2 times 3 power 3. It is nothing but 3 power 2 plus 3, which is equals to 3 power, which is equals to 3 power 5. So the law of exponent here is saying that if the bases are the same, we add the powers. And another law of exponent, it says that as long as we are dividing and the base is the same, and the base is the same here, it emphasizes that we subtract the exponent. So m minus n. For example, we are saying if the base is 2 and the exponent is 2, and we are dividing by the same base, which is 2, and the exponent is 2 again, it gives us an answer 2 power 2 minus 2, which gives us 2 power 0. And which gives us to another law of exponent, which says as long as the base is having a power 0, any number to the power 0 is 1, which gives us this answer 1. Any base with a power 0, the answer is 1. And also we have a law of multiple exponent. As long as there is an exponent which looks this way, it means we multiply the exponent. Multiply. So it means here we say times, right here n. For example, we are saying here, let's say 5 power 2 bracket power 2. It means that we multiply the exponent. 2 times 2, which gives us 5 power 4. So this is the law of multiple of exponent. And also we have a law of, we have a negative exponent, the law of negative exponent, where a base is having a negative exponent like this. So when you're having a negative exponent, we will have a bar 1 all over x. So this negative, this negative here, or the negative itself, will create what we call a bar 1. This bar here. So this bar represents the negative, and the exponent will go here. For example, we are saying 5 power minus 2. It gives us a bar 1, just like this, then 5, then we put a power 2 right here. And when we simplify, we get 25. So this is how we use negative exponent. So in the exponent also, we're having a fraction exponent. And the fraction exponent comes this way. And whenever you're having a fraction exponent, we end up having a radical or a root. Example, m will come right here. This denominator will come right here. Then we close the bracket. Okay. Then we put x here, we close the bracket, we put n outside. For example, 4 power 3 over 2. Okay, this is the negative, this is the fraction exponent. So when you are writing this, you write a square root. Obviously, this is 2 here, which is the square root of 4, bracket, nothing but 3. So which gives us 2 power 3, which gives us 8. So this is how it goes. So this is a fraction exponent. And sometimes also we are having equation in an exponent. For example, equation in an exponent, I'm sorry if I'm being fast, but you can pause the video and recap and try to find some other examples. So we are having also what we call equation of exponent. For example, 2 power x is equals to 2 power y. As long as the bases are the same, it means, okay, as long as the bases are the same, it means that x is equals to y. It means you cancel this here. But even if you are to apply logarithm, it will be log 2 power x equals to log 2 power y, which gives us x log 2 is equals to y log 2. So if you are to divide these logs, you remain with x is equals to y. So we say as long as the bases are the same, the exponent are equal. And also, sometimes you might have 2 here, power y. Or let's say, sometimes here you might have y power 2 is equals to x power 2. As long as the exponent are the same also, it means y is equals to x. The bases are equal. So as long as the bases are the same, you bring down the exponent. As long as the exponent are equal, the bases are also equal. Let us take a look into some mathematical examples. Exponent. Let us solve this example. Solve for n in the equation. This is an equation. So we are going to apply the laws of exponent that we've been discussing from the beginning of this video. So in this case, we are given 16 power 3 minus n times 2 power 1 plus n equals to, so we can actually see that the bases are not the same. So what do? We have to make sure that the bases are all the same. So for 16, we know that 16 is equals to 2 power 4 for 16. If you want to confirm, you can do prime factorization by 2. You find out 2 power 4 is equals to 16. And also, according to the law of negative exponent here, power 1, we said that it will be having 1 over x. So for example, we are having a half. A half will give us 2 power minus 1, because this one will be x power minus 1 back here. So it's like a reverse solution of this. So now, if that is the case, it means here on this equation here, it means you are having 2, okay, power 4, bracket 3 minus n, times again 2, bracket 1 plus n, bracket, which is equals to 2 or negative 1, as the solution suggests here. So if that is the case, here we have not yet formed an equation of exponent. So we needed to solve on this side, where we agree that as long as the bases are the same and we are multiplying, we add the exponent. So here we needed to add 2 power 4 obvious, 3 minus n, bracket, plus 1 plus n. This is equals to 2 power negative n. We're saying when the bases are the same, example, x power m is equals to x power n. When the bases are the same, you bring down the exponent, which is m is equals to n. So here goes, like, we cancel this. Even if we apply logarithm like what we did last time, we end up having 4 bracket 3 minus n bracket plus 1 plus n is equals to minus 1. Then we simplify here, we simplify the bracket, so we have 12 minus 4 n plus 1 plus n, nothing but minus 1. So 12 plus 1, we get nothing but 13. So 13 minus 4n plus an n, we get minus 3n, which is nothing but minus 1. So minus 3n is equals to minus 1. And this number will go here. And when a number jumps, the equal sign becomes a negative. I think all we know. Minus 3n is equals to minus 14, which will give us our final solution as minus 3n equal to minus 14. And we divide both sides by minus 3. By minus 3, we cancel here. N will be nothing but 14 all over 3. And this is an improper fraction. If you want to make it a mixed fraction, we'll get 2 over 3. So this is our final solution. Okay, let us take a look into another similar question. For example, here, find the value of x now in this equation. And here we can see that we have 1 over 3 power root x equals to 81 power minus x. And we can actually see that this is the law of fraction exponent, which is mixed with the law of multiple of exponent, something like that. And same goes to here, law of negative exponent. So here it's very simple, especially when you take a look into 81. And 81, if you are to do prime factorization, you can start by 3, obvious, here. So you can see 3 into 8, of course, you get nothing but 2, remainder, 2 into 21, we get 7, 3 here we get 9, 3 here we get 3, 3 here we get 1. So you can find out that 3 power 4 is equals to 81. So if that is the case, we can actually write like this, bracket, root x is nothing but 3. Instead of writing 81, we can say 3 power 4 bracket minus x. So this bracket represents 80, this represents 81. If that is the case now, we have a law of multiple exponent, law of multiple exponent, where we multiply the exponent. So you find out that we will have 1 over 3 bracket square root of x as a power exponent, which is nothing but 3 power negative 4x. Okay, so if that is the case, we have a law of negative exponent, where we have bar 1 x power 1. So you find out here 1 over 3 bracket root x will give us nothing but bar 1 3 here bracket 4x. That's what we get. So you find out this side and this side are the same, so we cancel and we bring down the exponent. We have root x is equals to 4 power x. So what do we do here? To remove a root, for example, we're having x is equals to square root of x. It means x is equals to x power half. So to remove a root, we multiply both sides by power 2. Power 2. We cancel here. Here will be x squared is equals to x. So if that is the case, we do the same. We multiply both sides by power 2. Here by power 2. And a root 2 will be multiplied. Root is like a half. So it will be dividing. Because we are saying a root here in exponent form or fraction. Exponent fraction. Exponent of fraction, it will be power half. So it means we'll cancel this and this one. We have x is equals to 4 power 2 is nothing but 16x squared. So you find out by the end of the day, we are going to divide x equals to 16 over x squared. We are going to divide both sides by x. And if you are to do that, it means here we are remaining with 1. Here we are remaining with 16x. And we divide both sides by 16 by 16. And if that is the case, x will remain as 1 over 16 as our final answer. So that's how we deal with the exponent. Okay, here is another example. And in this example now, we want to express x in terms of p and q from the formula here and find the value of x. So what we need to do, we need to make x subject of the formula first. So here we're having a root which is an exponent. So to make x subject of the formula, we say p is nothing but a bracket of q plus x power half. This is the law of fraction. And how to remove a power half, like I said, we multiply both sides by 2 here. So this half and this 2 we cancel, we have p square is equals to q plus x. So you find out by the end of the day, p square minus q is equals to x when this go here. So by making x or expressing x in terms of p and q, we find out x is nothing but p square minus q. After doing so, the question is asking us to find the value of x where p is 3. So you say p is 3, so 3 square minus q. Q is minus 1, so minus 1 here. So you find out here you get a 9. Negative times a negative, you get a positive. So we get this number. So x will be nothing but 10. So these are subject of the formula or transposition of formula mixed with the exponent. Okay, this is another question where it is asking if x power y is equals to 4. Find the value of x power 4y plus 1. So this kind of solution, you can actually say that it's very simple to solve. You just say x here, and we are told x power 4y. So you just factor out x or y times 4. So what you do, you just create something like this. Law of multiple exponent. Then plus 1 here. So if you create a law of multiple exponent, you find out x power y is 4. So it will be 6 times 4 here. But this 4 here is having a power 4 right here. So plus 1. So now the question is, what is 4 power 4? Now we are having 6. So 6 times 4 power 4. 4 power 4 is nothing but 256, right? Plus 1, which is equals to 6. Now we need to multiply 6 times 256. Okay, times 256, we get 6 times 6, 36. Okay, times 5 is 30. So plus 3, 33. Okay, times 2 again, 6, 12, plus 3, 15. So we get 1530 and 36. Our answer plus 1, which is nothing but 1537. So that's our final answer. In this case, we're having which one is greater? Cube root of 27 and the fifth root of 32. I think we are all familiar with this. You can do in math. We always emphasize on working. So you can do prime factorization. Check here. You get 3 here, 3 again, 1. So 3 power 3 is nothing but 27, which gives us 3 here, 27 is equals to 3. Or if you are to do prime factorization of 32, which is 2 here, 1, 6, 2 here, 8, 2 here, 4, 2 here, 2, 2 here, 1. So you find out the fifth root of 32 is equals to 2. This is the working. However, you find out that which one is greater now. You'll be saying, when you're writing 3 root 27 is greater than fifth root of 32. Only that. Let us take a look into this. Simplify the following expression. These are laws of multiple exponent. So if it's a law of multiple exponent, it's very simple. It's a power 3 times minus 3 times b power 2 times minus 3. So that's the concept. But one thing is missing. This number here. You need to multiply also with minus 3. If that is the case, if a number is having a power negative, it ends up being a bar. So we have it here power 3 times here when you are multiplying we get nothing but a power minus 9 times b power minus 6. So here we'll have 1 over 27 times, since it's a negative, we'll have a bar over a power 9 times bar b power 6. So if you are to make an LCM of all this, we have a final answer which is nothing but 127 a power 9 b power 6. Here is your homework. So I want you guys to simplify this. Upload a screenshot of your solution on the comment section below. Thank you guys for watching. See you on the next video. Bye bye.